Hey, how you guys doing? So after a deep ponder on my drive home, I figured out what he was meaning. So the question that we were talking about at the end of the optics quiz review today was the question from, if you go to lecture 12, June 27th, and just click on that in the modules, he has the question just written out there and an explanation on how to do it. And some of us felt like the explanation wasn't super clear. So thought about it, I figured it out, I'm here to share. So we're going to find what the accommodation, or what is the accommodation needed at the spectacle plane and the corneal plane. And this is for someone who has a -2 diopter spectacle prescription, so a myope. And their glasses are 15 millimeters from their eye, and they're looking at an object that is 20 centimeters from the front of the glasses. So, first thing that we want to do, since we're going to have to find the divergence at the cornea as well, is find what the contact lens or the corneal refractive error is equal to. Because we know the glasses is at -2. So the one that's at the refractive error at the cornea is going to be less than that. So we need to figure out what that is real quick. So we'll do that. We have a -2. So we're going to do -2.00. 1 divided by that to find the far point, which is going to equal 50 centimeters. I'll say -50, right? And then I'm going to take this and subtract that from that 50 centimeters, and that will give us the total distance to the cornea, right? And so that will give us a 0.5, my goodness, 1.5, I'm pretty sure, yep, meters. And then we'll use that distance to figure out what the contact lens prescription is. So it's going to be 1 divided by 0.515, and that's going to equal 1.94. Okay? So -1.94 diopters. So that is the prescription at the corneal plane. So I'm going to put that up here. -1.94. And I'm going to write a few decimal places so we don't lose it. 7447. As I write all of them, my goodness. Okay. So we've got that. Now I'm going to find, it's basically like a multiple lens problem where we're finding the divergence at the front surface of the first lens, at the back surface of the first lens, and then the front surface of the second lens. It's kind of like that type of question if you guys remember it. So to find the accommodation needed at the spectacle plane, I'm going to take the distance of the object, put that under 1, and that will give us a -5 diopter. So that's how much the object divergence is. And at the spectacle plane, we'll have to do the exact opposite of that. So that will be a -5, or excuse me, a +5. So that's the accommodation there. So +5 diopters of accommodation. Okay. Then we need to find it at the cornea. So we're going to find the divergence right after the lens, so after it's refracted by that -2. So that -5 will then, we're going to add it to a -2, and that will become a -7 diopters. That's right here. It will then travel this distance, and we'll need to find the divergence again right here. Okay, so we'll do, to figure that out, we do 1 divided by -7. 1 divided by -7. That gives us a 0.142857. And then we're going to, so that tells us that the far point is over here. We're going to subtract from that a 0.015. And that will give us a bigger distance of 0.15786. So because we're subtracting that 0.015 from a negative, it just makes it more negative, which just makes the distance bigger, right? So now we have the distance from here to that far point, right? Then do 1 divided by that, and we get the divergence right before the lens of that will be negative 6.33 diopters, okay? And so if this eye didn't have this refractive error right there, we would just stop there. But the eye will have to just do that much less accommodation. So normally it would just be a 6.33 diopters of accommodation, but we're going to subtract, we're going to subtract that 1.94174 whatever, and that will give us what the eye is actually going to accommodate at that corneal plane, which is a negative 4.393 diopters, or negative, that'll be positive, or positive 4.4. So that's basically how it goes. It's kind of a mess, but what he did, I'll just walk through the steps real quick, is we had the spectacle prescription, use that to figure out what the contact lens prescription is, because those would be different. And then you find, using the distance here, you use that to find the divergence right here, and then the opposite of that is how much it will accommodate you'll need to accommodate at the spectacle plane. Then go from here to the back surface of this lens. So you'll just add this to that to get this. That's the back surface. Then use that -7 to find the distance it travels here from its focal point right back there. This is a mess, my goodness. Then using that distance that you found from adding this to this, you get that, and use that to find the divergence right before it refracts, which is that. Holy cow. And if we didn't have the contact lens prescription there, then like for an emmetrope, they would just have to do plus 6.33 diopters. But I'm going to do this to that to get this. So hopefully that wasn't too much of a fever dream for everyone. But take home, don't worry too much about it. The take home thing is, when a myope puts on their glasses, they have to accommodate less than when they're wearing their contact lenses. How this depicts that, I honestly don't know. But just trust us on that. So, thanks. Oh, there was going to be some outro music.